is we are completing the square, okay? Today we are completing the square. This is another method to solve quadratics, but it's very specific in how you can use it, okay? Take a look at the form that it needs to be in order to complete the square. It needs to be in the form x squared equals bx. X squared plus bx. Guys, notice, how does this compare to our normal standard form on the left-hand side? German? There's no C term. Write that in there. We're missing a C term. In other words, our C term is equal to 0. Okay? 0. It's nada. It's gone. Poof. It disappeared. Okay? What else is slightly off here? Javansky? It's not equal to 0. Very good. Okay? We're only focusing on the left-hand side, but there's one small detail, guys. Does anyone see it? No, bx is fine.
It's not squared.
No. What's typically in front of the x squared? A. What is a equal to here?
0.
A is equal to 1. A must be equal to 1, and C must be equal to 0 to use this method. Do we write this down? Okay. Now, the reason that we need it to look like this is because what we're going to do is we are going to add our own C term. Highlight that C term, okay? We're going to add our own C term that will create a perfect square trinomial. Now, I guarantee probably the entire class forgot what a perfect square trinomial is. Perfect square trinomial is, so let's just do a little refresher. A perfect square trinomial is when you have x plus a constant, we'll label it C, and you square it. Okay? And what we would get here is x squared plus 2 times C times x, and then plus C squared. Okay? This was back when we were factoring. Okay? This is what we call a perfect square trinomial. So what we're going to be doing is we're going to be adding a C term that allows us to factor into x plus a number squared. It makes a lot more sense when we see an example, but are there any questions as of now? Hannah?
Should that 2cx be 2bx?
No.
Oh, okay.
Nope.
So there's no b in this?
There is going to be a b. This is just an example, okay? This C is not the C that we saw above. If you want to change that, actually, that's a good point. Change that C. Let's make it a different letter. What letter can we make it?
G.
Make it G, okay? Make it G as a constant, or G as a constant, okay? So G is just a number. Yeah, that C kind of was a little bit confusing, okay? All right, so how do we figure out what G needs to be? There's a 3-step process. That 3-step process is listed for you down here, okay? So you're going to be given x squared plus bx. The first step is you have to find 1/2 of b. How could we find 1/2 of b? Multiplying it by 1 over 2, or dividing it by 2, right? b over 2. That is step 1. Step 2 says square the result from step 1. So you're going to take b over 2 and do what with it? Square it. That number you add to the result from step 2. You add that to your original. So go ahead and stick on plus b over 2 squared. So whatever you got in step 2, you're adding that. That's going to be your C term. That's going to be your last constant in the trinomial. Once you've done that, every single time it'll factor to x plus your b over 2 squared. Your b over 2 was what we calculated from step 1, okay? And this works every single time. It's a very useful method, but it's very specific, okay? Now, the two requirements, if you remember from back in the beginning, A had to be equal to
1.
and C had to be equal to 0. Okay? So in every single example, make sure you're checking for that. Are we clear?
Yes.
Okay. Now on your test, I am going to tell you which method to use. Okay? So you don't necessarily need to remember this. Okay? Let's take a look at the first example. Let's identify our A, B, and our C. We've got x squared plus 6x. Our A is equal to? 1. Our B is equal to? 6. And our C is equal to? 0. Okay? Can we use completing the square here?
Yes.
Why?
Because A equals 1 and C equals 0.
A is 1, C is 0. Put check marks next to them, making sure that you checked that we can use it here. Are we Gucci so far? Okay. Now, the next thing that we have to do is write step number 1. Does anyone remember what step number 1 was? Sophia?
B over 2.
B over 2. B over 2, where our B is 6, so we're going to put 6 over 2, which is 3. Please, please, please highlight the 3. That is very important, okay? We're going to make a connection at the end. Step number 2. Diego? You square it. So we take 3 and we square it. When we square 3, what do we get? 9. Two things to notice about this 9. This number will always be two things. It'll always be a perfect square. What else will it always be?
A number.
It's yes, it will always be a number. What?
I don't know.
Any ideas?
It'll always be odd.
Positive.
Oh.
Okay? It will always be a perfect square and it'll always be positive. Why will it always be positive?
Because you
Jordan? You can square a negative number.
it'll just no.
You can square a negative number. Javonsky? Very good. Anytime you square something, if it was negative to begin with, is it going to be negative when you square it? No. Okay? Whenever you square something, it will always be positive. Okay. So then step number 3. This is the part that I lose some of you. Pay close attention. Take your original expression, which was x squared plus 6x, and you're going to add your C term from step 2, which was 9. Now, this one, we're going to take step by step, and then I'm going to show you the shortcut, okay? Now, we're looking to factor this, right, into two expressions that are being multiplied by each other. So we need to look for two terms that add to give me what? 6. And they multiply to give me? 9. What two numbers are they? Adrian? 3 and 3. If you factor like this, you're Gucci, but you will always have the same number here. Write that down. These two will always be the same number. Do you see they're both 3s?
Yeah.
They'll always match. Okay? Hold questions to the end, guys. Hold questions to the very end, okay? Because I might answer your question as I go along here. I understand you guys have questions. So, this is going to factor to x plus 3 and x plus 3. Do you guys agree that I can rewrite this as x plus 3 to the second power? Yes. This is our factored form. Now, you might be asking, do you remember when I asked you to highlight the 3 from step 1? Check it out. That number will always match what's next to your x. You can skip pretty much all the steps and write it like that, okay? Now, the reason we're writing all the other steps is for later on in the process, okay? So you have to remember all the steps because later on you're going to need those steps for other examples. Are we Gucci here? Now, the shortcut is to remember that this 3 is going to be the same as this 3, and you can just factor it like that. So what you're cutting out is this part right here. You won't actually have to look for the factors. All right. Questions on any of the steps? Hannah, you had a question, right?
Oh, I was going to ask if that was the correlation between the 3.
Yes, that is the correlation between the threes. Preston,
How do you get like the 3 squared
from where?
from the top?
Got it. Step 2, right, is you square whatever you got in step 1. Okay? So you have to remember what you do in step 1 and 2. All right? It's going to be the same process every time. Good question. What other questions? Hannah?
What I'm worried I'm going to do is that for step 1, I'm going to put negative b over 2.
No.
I feel like I'm going to do that.
Okay, that is totally appropriate. I hear that. Negative b over 2a is to find what? Axis of symmetry, okay? This is completely different. I understand there's a lot to remember. How do we get good at this? Practice, okay? All right, do not do B yet. Go B. Are there any other questions before we get to B? All right, check it out. B is going to be a little bit tougher because we're going to have a fraction. That's the only difference, okay? What is A here? What's B? And C? Can we use complete the square? Why? A equals 1, C equals 0. Don't sound so bored, okay? Step number 1. B over 2, which is going to be? Negative 9 over 2. Someone tell me, does this simplify? Should we be absolutely thrilled that we got a fraction? Yes, okay? So we got negative 9 over 2. Step number 2. Wait, actually, you can already shortcut to what your factors are. Does anyone think they could jump to step number 3 at the very end? Jasmine?
In parentheses, x minus 9 over 2 squared.
Very good, okay? Now, you can jump to the very end. I'm telling you guys right now, do not jump to the very end ever, okay? We know what the answer is going to be, but you need to fill in the rest. And the reason the rest is important is because the next examples that we do, the second part of this question is the whole part of the question. Like, that is the most important part, okay? So do not do all these examples by just jumping in the end, okay? Fill in the work. So what was step number 2, guys? Square it. So we're going to take negative 9 over 2, and we're going to square it. What do I get?
9 over 2.
No.
18 over 4.
Nope. 81 over? Is it positive or negative? Is it a perfect square? Yes, because 81 is a perfect square and 4 is a perfect square. We Gucci? Okay. Now, we rewrite our expression as x squared minus 9x, the original, but we add what to it? Brandon? Plus 81 over 4. And that's going to factor to negative 9 over 2, or x minus 9 over 2 squared. Brandon? Yes. Andrew?
So we have to do like that in the test. We can't like.
Absolutely, you have to do this. Okay? Because look, it's saying complete the square for each equation, then factor each trinomial. This is considered completing the square, adding your C term. This is factoring the trinomial. Understood? You would only get half points. Okay? The shortcut, why did I tell you about the shortcut? I mean, you know what the answer is going to be. Would you rather me not tell you the shortcut?
So you can check.
Okay. Questions? All right. Now, down to C. Go down to C.
I'm now afraid of B.
Okay? In C, we've got x squared plus 10x. Let's take it step by step. A, B, C. What's A? What's B? What's C? Can we use completing the square? Why? A is 1, C is 0. We Gucci so far. Okay, what was step 1? B over 2. It's going to be 10 over 2, which is 5. Highlight the 5. Are we going to use that later? You bet your butt we will. Okay. Step number 2.
I don't have it.
B, no, not B squared.
I swear.
What you got from step 1 squared. What do we get for step 1?
25.
No, we got 5.
Oh.
Then we square it and we get 25. Always check that this number is
Also square.
positive and a perfect square. Is it both of those? Yes, we can move on. Step number 3.
You plug it in.
No, you don't plug it in.
Well, I mean, like I see.
You add it as c. So we're going to get x squared. Guys, be very careful of what you're saying because what you say is what you think. And you might get confused. So x squared plus 10x. What do I add here? Plus 25. Now, if you're that kind of person that likes to go through all the steps, you're looking for two factors that when you add them, they give you 10. And when you multiply them, they give you 25. You're going to get what two factors here, Adrian? 5 and 5. Those numbers should always match or sometimes match? Always match, okay? So, our two factors are x plus 5 and x plus 5, which simplifies to x plus 5 squared. Now, the shortcut, when we get to this step, how could we already know that x plus 5 are our factors? Javonsky?
A and then like the n from our perfect squares.
Yes. Okay, that's a good point. Marcio? By looking at step 1. You can bring down step 1, check it out, and just write x plus 5 with what? A squared. Do you guys see how we match the same thing? Do I care which method you use? Is the second one shorter? Should we probably know the second one? Okay. Any questions, Hannah?
Could we do the first one to double check that we did our math right?
Yes,
in case, like, our
absolutely.
brain just didn't work for a second?
That is an excellent point. So, if you finish the test early, do you think going back and doing it the other way would be a good way to check your work? Absolutely. Okay. Now, let's go ahead and tackle. Actually, hold on. We need to touch on this slide, okay? Now we are going to be solving quadratic equations by completing the square. Underline equations. Before we were dealing with expressions. Did those have equal signs in them? No. Now we're going to have an equal sign. Check out this equation written down here. Okay? My a value is still equal to what? 1. And my c value is still equal to what? 0. Some differences to point out. Is this in standard form? Why not? It's not equal to 0. Therefore, is not in standard form. Now, contrary to popular belief, when you're using this method, you should not be in standard form. Okay? So if you have a constant, you're going to move him to the other side of the equation. You want your expression to look like this. Do you guys see that? Okay? So your c term is still 0, your a term is still 1, but it's not equal to 0, it's equal to a d term. Okay? Now, could we change this into standard form? Yes. What would we do? Subtract d from both sides. Are we going to change this into standard form? No. Not for completing the square. Okay? So let's check it out. See some examples. Wait. Take a look at example A. Is this in the desired form? Well, let's check. What is my a term? It's 1, so that's good. B is equal to? That doesn't really matter, okay? But we do need it for later on. What is C here? 0. And what is D? Is this in the right form? How do you know?
Because c is equal to 0, a is equal to 1.
C is equal to 0,
Standard form.
A is equal to 1. It's not in standard form. Are we on the same page? Okay, so we're going to do the same steps. What was step number 1? B over 2. In this case, it's going to be negative 16 over 2, negative 8. Yes? Okay, make sure we highlight that because we are going to.
Come back to it.
Yep, we're going to use it later. Step number 2, square it. So it's going to be negative 8 squared, which is 64. Is it positive? Yes. Is it a perfect square? Yes. We're Gucci, okay? Step number 3. This is where things mix up. Put a star, okay? This is where things change for this method, okay? Listen carefully. Do you guys agree? In our last example, we would take x squared minus 16x and add 64 to it? we're going to do the same thing. X squared minus 16x. We are adding 64 here. Equals negative 15. But guys, are you allowed to, in an equation, add something to only one side of the equation?
Oh.
No. What do you have to do in order to have balance in your equation? You have to add it to both sides. So if we added 64 on the left, guess what we have to do? Add 64 on the right, okay? Now, a bunch of you are going to have an epiphany in about a second, okay? This part on the left, x squared minus 16x plus 64. The reason we did all of this is so that we can factor it. What does this factor into?
X plus 8 squared.
No. X minus 8 squared. It's all in the details, people. It's minus because why?
That's what it was.
There was a negative 8 up here. Are we all going to see that on the exam? Okay. Now, this is equal to what?
49.
49.
That's what it was.
Okay. 64 minus 15 is 49. Now, guys, this is a very, very important step. Take a look at this equation. Does anyone recognize how we could solve this equation using what we know from the past? Javansky? Very good. This is a square root problem.
Oh!
Okay. Now, listen carefully. The whole reason we do completing the square is so that we get a square root problem. Okay? Now, all we need to do to solve this is take the square root of both sides. Whenever I take the square root, I'm going to be super careful and always remember plus or minus. Yes? Okay. Now, someone who's been working hard, what am I going to get on the left-hand side? X minus 8, because the square root and the squared are going to cancel. And my right-hand side one? Plus or minus 7. I guarantee people are going to say just 7 and mess it up. Okay? Now, we have two things to do here. What's one of the equations I need to set up? One?
X minus 8 equals negative 7.
Good.
X minus 8 equals positive 7.
Very good. I break it up because I have this plus or minus. Do we all see that? Okay. So, what is x minus 8 equals negative 7? What am I going to do to solve that? Sebastian? I don't care. You know how to do that.
What was the question?
How do I solve this one on the left?
You gotta add 8 to both sides.
Good. What do I get?
You get x equals positive 1.
Positive 1. Okay. Who can do the one on the right? Adrian.
Add 8
Okay.
both sides. You should get x equals 15.
Bingo. How many answers did I get? 2.
The square on the x in the beginning was 2.
Is this a lot? Yes, it's a lot of work. I'm not going to lie to you, okay? Are the steps hard themselves? But is it a lot to remember? Yes, okay? How do we get better at this? Practice, okay? All right. Let's do B. Yeah. Not yet. Yeah. No. Okay. Hey. B. What do I do? A, B, C, baby. A is equal to? 1. B is equal to? Negative 2. C is equal to? And what do I add here? D equals 3. Can I complete the square with these numbers? Why? A is 1 and C is 0. And it's not in standard form. We Gucci? Okay. What was step 1? B over 2. In this case, it's going to be negative 2 over 2, which is negative 1. Is this number going to be important?
Yes.
You bet. Okay. Step number 2.
Negative 1 squared.
Negative 1 squared. Do I get negative 1 here? Positive 1. This number should always be positive and?
A perfect square.
Is it a perfect square?
Yeah.
Is it positive?
Yeah.
We're feeling really good now, okay? Now, we go ahead and write step number 3. Who remembers it? Sophia?
You add into the equation, so
On both.
x squared minus 2x plus 1 equals 3 plus 1.
Good. What was the whole purpose of us adding 1? Just because this is the method, Preston?
So we can make it into a square root.
Very good. We can factor it. What is this going to factor to? Sophia?
X minus 1 squared.
X minus 1 squared. Guys, where is that minus 1 coming from? From step 1, yes? Okay, now we set this equal to 4. The plus or minus does not happen until we do what? Take the square root, okay? Once we take the square root, then we add plus or minus. Are we all on the same page? Okay, so we get x minus 1 equals plus or minus, not 4, 2. What do I do next?
Then we put x minus 4 equals minus 2. I mean negative 2, and then x minus 4 equals 2.
X minus 1 equals negative 2, and x minus 1 equals positive 2. Yeah, you said 4 twice. Okay, what do I do, guys? You add 1, add 1, add 1, add 1. X equals negative 1, and x equals 3. All right, try C, go.
That's the same thing.
Nope. Yeah? Yes. So, okay, take a look at the board. If you got to the step where I boxed it in, you did it up until the point where we know how to do this problem. So give yourself a pat on the back, okay? Now, why is this problem different than the 2 that we did before? Javonsky? This number is not a perfect square, okay? Write this down. This is an example where this is not a perfect square. I can't spell. Thank you. I do get an exception because it's Teacher Appreciation Week, and I am a math instructor, not an English one, okay? All right, now, let's think about this one. How would we still have to get m by himself. How do we get m by himself? Jordan? Subtract 6 from both sides. So we're going to minus 6. We're going to get m equals. Always write the number without a radical before the number with a radical. What's the number without a radical? Negative 6 plus or minus the square root of 28. Can we add negative 6 and 28?
No.
Why not?
They're not in the same party.
They're not in the same party, okay? One has a radical, one does not. So this is technically our final answer, with the exception that if we write an answer, it better be completely simplified. Can we simplify the square root of 28? Yeah. Diego? Negative 6 plus or minus 2 times the square root of 7. Bingo, bango, that's the right answer. Andrew?